What's up, guys? Welcome to topic 8, notes using the quadratic formula. So when would you use the quadratic formula? Okay, so the quadratic formula is basically help us with some nasty problems. Like this right here is a very, going to be a hard problem because first of all, we can't factor anything out, right? There's no GCF. There's no common factor between 8, -3, and 22 that I can factor out, which means when I go and find my factors, it has to be 8 times 22. That's a huge number, and then you got to figure out what subtracts or adds up or subtracts to -3, right? So that is an ugly problem, and you use this to help you with that ugly problem instead of having to do all those steps. We could still use it for problems like these, right? X squared plus 3x minus 10, but the X factor method is much faster at getting my answer because it's a little tedious. It's a lot of steps. So here's what we're going to do. We're going to use this for problems that don't factor easily. So let's go ahead and get started. Then the X factor method is pretty straightforward. All you have to do is really find your your B value, your A value, and your C value, you plug it in, and then you're done, and you just solve it. So that's very straightforward. Let's go ahead and get started. So first we need to figure out what are my values. What's my A value based off of this over here? What's my A value, B value, C value? My A value is 1. B value is -6, C value is 4. Now what I need to do, I need to substitute these values into the quadratic formula. So I have negative, parentheses, -6 plus or minus square root of B squared, so -6 squared minus 4 parentheses, my A value, my C value, all over 2 parentheses A1. All right, this is exactly what I mean. It's tedious. There's a lot of steps, and you have to make sure that you do them correctly, because if not, you can get an error. You could get the wrong answer very easily. Now, here's what we need to do. We're not going to type this exactly like this into the calculator, because more than likely, our answer is going to be a radical. And here's an example. My answer will look something like this. -6 plus or minus 3 square root of 2. And I want you to leave it in radical form. I don't want a decimal. So radical form means where you have this square root. You have a square root inside of it. So let's go ahead and simplify. So here's how we do this. We're going to do this in steps. We're going to simplify this part here. Then we'll simplify this here, and then we'll simplify that. And if we can go further, we'll go further. All right, so real quick, let's do the first part. -6, let's do this part right here. -6 times, negative times a -6 is going to become a +6. Awesome. All right, I'm still going to write the plus or minus. I'll explain that towards the very end. Then I'm going to do the square root still. Now I need to simplify everything under the radical. So what is -6 squared? That is 36. All right, and what is this simplified, right? -4 times 1 times 4. That is a -16, right? All right, and then in the bottom we have just 2. One more step. Let's simplify the radical right here. Let's simplify what's under the square root. I have 6 plus or minus square root of 20 over 2. Now, we would think we're done here, but we're not. Remember when we did simplifying the radicals, and I had to see if there was, I did the prime factorization tree, right? And I had to figure out, hey, there's 2 of the same numbers, those can be pulled out, and then whatever's doesn't have a pair, stays inside. That's what we need to do. All right, so let's go ahead and do that real quick. So if I wanted to simplify this radical, what are 2 numbers that multiply? So 4 and 5. 5 is already prime, but 4 has 2 and 2. Okay, so here is a pair. The 5 stays under the radical. So here's what I have left. I have 6 plus or minus 2 square root of 5 all over 2. Okay, now here's where it gets a little tricky. This right here, this plus or minus, tells us that I have 2 answers. Okay, it has 2 answers. One of them looks like this, right? Let me separate it from here and to here. Okay, one of them looks like this. 6 plus 2 square root 5 over 2. And the other one looks like this. 6 minus 2 square root 5 over 2. So I basically have like two expressions up top, okay? And then you would simplify further if you can, and in this case you can because I only want to focus everything that's not under the radical, right? So the 6 is 2 and this 2. Do they have one number that's that they're both, common? So 2 divides into 6 and 2 divides into 2. So really this simplifies to 3 plus square root 5. And this right here simplifies to 3 minus square root 5. All right, now I know this seems like some alien stuff. You're like, what in the heck did I just see? This right here is called the quadratic formula, and this is how you use the quadratic formula. You plug in your values and you simplify. Now this is what I'm talking about. If you plug in 3 plus square root of 5, you're gonna get this long decimal, and I don't want you to round a decimal. I want you to leave it in radical form. Leave it just like this, because I have to keep. Then we have to figure out which decimal to round to and all that stuff. You could plug it in, but you're just gonna get a long decimal. All right, so here we go. So we have that as an answer. Now that's using the quadratic formula. Now let's go ahead and let's do a few more of these examples, and then you guys will be set for your homework. All right, so again, this right here, we don't have it in standard form. We need to have it in standard form like this, sorry. Ax squared plus bx plus c in order for us to get my a, b, and c value, right? We need to do that. So let's go ahead and do that. We know that this right here is a perfect square trinomial, so I can multiply that out. So go ahead and do the box method real quick. Bam, bam. So we have x minus 4, oops. All right, so this is x squared minus 4x positive 16. All right, cool. So now I have x squared minus 8x plus 16 equals 36. It's still not in standard form, right? Because we need all my terms on one side of my equation. So this one right here, this 36, we need to cancel it out and bring it to the other side. How would you do that? You would just subtract, right? So let me do the opposite, minus 36, and then minus 36 here. So what do I have? You have x squared minus 8x, and this is going to be minus 20 equals 0. Okay, I know that was the first step. Now what we need to do is we need to go back, and we need to plug this into my formula just like we did there. There's going to be a few steps, right? All right, so let's do that. Did I skip this example? I sure did. That's all right. We're doing multiple examples. I'll come back to that one. So remember, it is negative b. So let's just write my values real quick. So I have my a is 1, b is negative 8, and c is negative 20. All right, so let's go ahead and plug it in. So we have negative b, so negative parentheses negative 8, plus or minus square root of b squared, so negative 8 squared, minus 4 parentheses, that's ac, bam, negative 20, bam, okay, all over 2a. I know it's a lot, right? And it's supposed to be x equals the very front. It's a lot, but this is what we use to help us take these nasty problems and make them easier to solve, right? Especially if we can't factor them easily. All right, now what we do is just simplify, right? We need to do in baby steps. I need to simplify this part here. I need to simplify everything under the radical, and then you just simplify down here. So we have 3 steps. So let's go and simplify. I know in the beginning, I'm gonna get a positive 8. So plus or minus, and then let's see what we can get under the radical. So we have, I'll just take my calculator and redo that. We don't always have to do it by hand. Sometimes it just likes to. All right, so let's see. Delete that. So we have parentheses. I'm just going to type what's highlighted under the radical. So negative 8 squared minus 4, 1, parentheses, negative 20, bam, enter. So this is 144, right? And then what do we have here? 2. All right. Now, if we can't simplify this, if this is not a perfect square, and in this case it is, if it's not a perfect square, then we have to go back to the old method of this right here, right? Because negative 20 is not a perfect square. There's not one number that I multiply by itself to give me 20, right? So that's why we had to simplify the radical. But we do know that the square root of 144 is a perfect number. So really, to be honest, this one we could plug into the calculator, and I'll show you it. So we have 8 plus or minus 12 over 2. Then, remember, this plus or minus means I have two answers, and I have to separate them. 1, 1. All right, so here's one answer. We have 8 plus 12 over 2. There's one of my x values. I got to solve that to figure out what is this x value. And then I have 8 minus 12 over 2 to get my second answer. All right, so 8 plus 12 is 20, divided by 2 is 10. So here's one of my x values right there. Bam, bam. It's not a negative 10, it's a positive 10. All right, so we have that. And then let's solve the other side to figure out what the other side is. 8 minus 12 is a negative 4. So we have negative 4 over 2, which is a negative 2. Bam. So there are my two answers right there. Now that is using the quadratic formula. And it's not hard, it just takes a lot of steps. I won't complete these examples right here because it's very straightforward. For this one right here, what would I need to do? You would need to first put it in standard form. All right, so what I would need to do is you need to get all of this to the other side of the equation. Now, how would you do that? Very briefly, if I wanted to cancel it out on this side, to move it to the other side, cancel out is inverse operation. So I would add 6x here, I would add 6x here, so then you would have x squared plus 6x equals negative 10. And then you would have to add 10, right? So then you would have x squared plus 6x plus 10 equals 0. And then that's not your final answer, but that's what you use to plug it into the quadratic formula. All right, so that completes your notes for today. Thanks for watching. If you guys have any questions, please come to my tutoring.